Um, so for everybody seeing my screen, right? Everybody could hear me well?
Yep.
Professor.
Awesome. Thank you. So thanks for confirming. I do see 17 people. That's good with me. So 16. It's going to be added more people as soon as they are here. Agenda for today, we will cover for the lecture assignment operators. We're going to cover variables. We're going to cover conditions. We're going to cover statements. We're going to cover if statement, maybe while statement, maybe for statement, a combination of all those looping structures. We're going to discuss, last week we also discussed algorithm and what's a programming language. We're going to expand on those and then we may just download and install Python or just upgrade the Python depending on what you already have. I will show you both. And then we also show you interactive Python and then running Python script on the command lines, running Python modules, and then how to import modules. And then, as I mentioned earlier, variables, condition, statement, if statement. The data types and data structures, we're going to cover some examples of integer, float, Boolean, complex, the string, set, list, tuples, data dictionary, everything. And so, and then I'm just gonna have to remove this lecture here, it's duplicated. Python idle, we're gonna discuss that, what is idle, what is IDE, integrated development environment. We're gonna cover that, and so that's a summary of what we're gonna cover in the class, and your book is already covering a lot of it with different chapters. Chapter 1, 2, 3, and 4 is basically some of the concept that we will be covering in the next 2 weeks. Chapter 4 is mostly like functions. Chapter 1 and 2 variables and statement and conditions and other related materials that we cover in Python. And then on the lab exercise, we will be covering a lot of these examples, each one of them. I'll show you, for example, how to do it when you do it on Windows and how to do it on Linux. Those kind of information is all here for you to run. And then on the exercise right here, I mentioned that you need to just make sure that whichever editorial that you're using on your Windows or Linux or Mac platform, make sure that you are writing the name of the program. If the program is Hello World, and then your last name.py would be the name that you save it as. And inside of it, you put the pound bang Python if it is a Windows platform, and for the Linux, using maybe VI or Emacs or Nano or any editorial that you choose, Vim, whatever you choose, you just make sure that you put the first line as header of the information, user Benny and V and Python with shebang. This symbol is called shebang. So you use that one, and then after that one, you start your code in Python syntax. And then the syntax and semantics are what the code's gonna just be interpreted when you put it into the Python interpreter. And the syntax has to be correct. If the syntax is correct and the logic of it, which is semantic part of it, what it makes sense, it has to work. So that part is basically part of your programming language syntax and semantic that makes your code. And inside of it, the way you write the steps of a sequence of steps to carry out a task to compute something, in order to do it, you write an algorithm. An algorithm is a finite set of sequence that you just use in order to just carry out a computation inside a computer processor or CPU and memory and everything. So basically you're giving instruction to the computer how to carry out a task, and those instructions step by step how to do it is called algorithm. And the short version of algorithm definition is a finite set of sequence of computer instruction and that carries out a task. It's exactly important that you say finite. It's not infinite. Otherwise, it would go to an infinite loop. It will never compute anything. So it is maybe 5 steps, maybe 2 steps, maybe 1 step. You say print hello world, it's just 1 step. If you just say for I in this range, do this, and then you carry out some task and do some computation, maybe you do 5 different statements to do it, and that's the steps that you still do some computation. So it's a finite set of a sequence of instruction that you gave to the computer. That's what algorithm is. And last time, I'm not sure if it was in my this section or the other section, I already had Python 3.5.3. I upgraded to Python 3.3. So the latest Python version that is available, you need to make sure that you upgrade it. So I'm going to show you starting with Python first, and then we go down to the list of these items one by one and cover up as much as we can cover in details so you understand the rest of it. In order to do that one, let me just go to python.org first. So python.org is the website that Python documentation, Python binaries, Python downloads, everything that is all the availability is on this website, python.org. And then if you click on the downloads, you can see the latest version that is there, Python 3.8.5. So since I have the Python 3.8.5, even if I download it, you can see that it comes out with number 1 here. So I don't need this one. I could just say I already downloaded Python 3.8. So I'm going to go my command prompt. In order to do that one on Windows, you type in cmd at run, you will get a command prompt. And then once you open up the command prompt here, if I just want to know that what version of Python I'm currently running, so on my machine, like you see on the download page here, on the download page is Python 3.8.5 is the download page of Python. So on Windows, if I just bring my Windows command prompt here and type in Python-V with uppercase V, it tells the version that I have. So my Python and that Python version that is available is the same thing. The reason it is the same, because last week for this class or my other class, I downloaded the Python, and then Python 3.8, you can see that there's 0.5 is already there. So I don't need this one, which I canceled it, but it already had downloaded it. You can see the size of the file is the same file, so I'm going to delete that one. In order to delete that one on Windows, you could say del, and then if you see that the problem with some of the file name, as soon as you have this directory, the file was already there. Since it got a new copy, it put a space here, right? So on Windows, in order to get rid of a space, you could just say double quote Python dash 3.8.5 greater sign, I mean the parentheses 1.exec, and then this. This would also do the same thing. So if I don't want to delete it, I do a directory to see if I get the list of that file. Yes, it reports that one. And then this is one format. With the old DOS version, you could put the 7 character of that file with tilde1, and then it would pick up this one, tilde2 would pick up the next one, and so on. But since the escape finds it, another way you could do is to say, if you don't put the let me small size it, make the window smaller. So right here, and I'm gonna just cover up that window. That's good enough. Okay, so if I just want to do this, I could also do this command with the Windows operating system. I could say dir, and then if I just don't use the this symbol, I could use the wildcard symbol. So I could say up to this, I know it, then a star, and then after that, I don't care what it is, as long as I'm looking for the number one there. I could even put after this one another asterisk, whether it's .exec or anything, it will find it. So there's, within the double code, you can search it like this, you could find it, and then within the other one. There's also commands that you could search under, like for example, if I say find star Python star.exec, right? I could see all the ones that are there. And if I want to do subdirectories, I need to think more. The slashes would do the flag of subdirectory. But the reason I'm showing you these commands, sometimes you run into a Windows operating system and you're looking for certain things. It's good to know these things, and then that way you could manipulate the right file and delete it. So I could say delete this, and then star one star.exec, and that would also take care of the same thing, because the other one does not have a one. So if I just do this command that I was doing here earlier, it will not show anything because I deleted. But if I just say, show me everything with .python, and then .py5 is there, which is the one that I want to save. So if I wanted to upgrade this one, I had to run this program Python 3.8.5 to make sure that I get -- version is equivalent to Python -v, uppercase V. Sorry, Python with one dash. -v and -- version is the same thing. So if I just want to say, okay, I have Python 3.58, can I just still run it? It's not going to just do anything. It's just going to say, well, it's already installed. You want to install it. When it does install it, in Windows, it updates your path environment variables. And notice my Python path, I have two versions. One is for 3.7, which was installed under the user directory, app data, and then the other one is 3.8. There's both 32-bit, so they just show 3.8, and then the minor version of -0.5 is not showing there, but it is actually there. So if I just say what version I have, if I just do this, that would say 3.5. I could also say Python, and then that also point me to 3.8.5. And if I just say import a module called sys, remember I was saying that we will cover some of the modules as well. So from time to time, I may import another Python modules that are related to the subject that we are discussing, so you understand what we're doing. Like here, I'm importing Python sys module, and then when I do a dir of sys, this dir command, which you're going to see and you're going to practice here a lot later on today, is one of the commands that we will cover, right? So when I do a dir on that module that I did load it, it will show me a directory listing of all the method, and then dunders, and then properties and methods and functions that are available for that module. Everything here, you see this underscore, double underscore, and then doc underscore, they're called the dunder methods, or the magic method. The reason it's called dunder, dunder is spelled like this. Okay, dunder, D-U, is like double under. That's what they stand for. Dunder stands for double underscore. So all of these ones that you're seeing with double underscore in front of it, it is by default or there. So if you just exit out of here and then say Python, and then at this time if I do dir of all the objects without loading anything, by default, depending on what version of Python you use, certain dunder methods are being loaded automatically. For example, the underscore built-ins has all the functions and attributes or properties that are there. Like, let's say if I say print underscore built ends underscore, and then run it as a method, and then do a help on it to get what are the methods of it that is available. It is a big list of all the built-ins. So all the built-in function, exception, and other objects are listed here. You can see that there's a big list. This is within Python. But let me go back after this. So I'm gonna quit out of this one, exit out, and then go back to the concept of what I was talking about, Python version and Python itself, and then import the sys module. Now, if I do a dir of sys, notice that there are some related variables or properties like version underscore. So I could say sys.version. You could see that it is basically telling me that this is Python 3.8.5. And then this Microsoft C, and then Intel version of it on Intel platform, and it was built on July 20th. So if I do underscore version underscore info, then you will see that the major and minor for it. And then, like, for example, if I say sys.path, this is just basically showing me the Python modules. When I compile something, by default, every module that I compile is going to look at my current directory, which is where I started Python from the current directory. And then it's going to look for the Python 3.8 zip files that all there. So the current directory is appended here, and then program files, DLLs, and then at the same time the site files. Somewhere here is for the site packages. They're all together. So it is like the sys module is somewhere in the 32-bit executable that it finds it, and then the math modules, all of these ones are found in these packages. These site packages are all vendor-based related device drivers and anything that needs to be loaded or just there. We can look at those files someday and say, okay, let's go just CD to this directory and look at all the modules there too. Okay, so just to show you that one, so we don't leave anything as mystery, I could say a directory of this path, let's say, for the lab, and then the site packages are there. So I'm going to just do up to this, and then we have to close this one there because there's a space. Okay, so this one is actually showing you two underscores with the slashes. Normally the operating system doesn't care about the two slashes, but what I want to do is CD to that directory to make sure that I can go in there. So let me just do double quote C : / program star files star 86 star. First, let's see if it does go there. Yeah. So then I could do Python, and then inside there is 32-bit lib, so 32, and then CD to libs, and then the side packages, if there are any there, and then Python 3 lib. So let's go to Python. These are actually .lib files, they're not directory. So this is all the library files, and then inside, okay, the DLL, and then tools. Let me just go back to that Python, import sys.path, and then exit out. So I'm going to go to program files, yeah, libraries, Python 32-bit. Okay, let's go to the same directory we went there before. CD to Python, and then DLLs 32. So Windows doesn't care if you type in uppercase or lowercase, it converts everything to the PyC directory. Let's say store.pyc. We're looking for anything with the extension of .py. So all of these modules in these subdirectories or modules that are available for Python, you can see that there's a big list of them. So if we look for something like something sys star, it's going to be like a number of them, and then just the sys itself, you can see the sysconfig is there and the other stuff. With math modules, you could do the same thing and look for all the math modules and NumPy and so on. All of them, that when they get downloaded, basically under these side packages and based on certain subdirectories are getting this. This PyCache is the Python compiled version of something. When you compile it, it gets executed as .pyc. It will create a PyCache files. But those are not introduction things, so I'm not going to jump in back to all those things. Let's just go back to original discussion, so we're not getting off of the topic, and I'll cover what we need to cover. Okay, so right here, we were talking about the Python version. So the version is 3.8. I already have that one. If you don't have it, basically, you're going to go to Python, you download it, and then run the executable, and then you will have a command line Python version. So no matter where you are on command line, like here, I could type in Python, and it dropped me to the Python interpreter. Starting here, I could just create variables, say x is equal 5, and then print the variable x, or just print x like this, or print 5 plus 5, and then that would be that, or you could just say plus 5, and then you say that the shortest path to addition is multiplication, so you could say 5 times 3 is 15. That way you could do the same task, and then you could just create different data types. But let me see, once we are here on the topic of Python. So we did install Python already, and we are running Python from the command line. Upgrading, since my interpreter was 3.8.3, I upgraded to 3.8.5, and there. Upgrading already, running Python interactively. So we're running Python interactively right here. So the way you run Python interactively, you just from somewhere, you could either type in exit or quit, it will take you there. So no matter where you are, you just say path, it will show this Python version that is there, and the executable. That means you can say Python to just get there. You could also type in Python .exec, it will get there. And then you could also put the full path of where the binary is, that is there. But because it is already in my path, I don't have to know the full path. I don't have to type in the full path of the binary wherever 3.8 program files for Python is, right? So it's somewhere here, program files. And if you forgot that one, let's say something like this, this path environment was too long for you to parse it to say which one it is there, you could use other commands to help you out. For example, you could say path, send it to a file called p.text. And now, since I'm on the root level and I'm having a regular command prompt, I could not create files. So I'm going to go to Tim directory, cd to Tim directory. Now I can do the same command here. It will create the p.text. And then now if I just want to say type p.text, it is there. But then if I just want to say notepad p.text, opens it up. Notice this line is really huge, right? So I could search for it, say find Python. And it is going to find that path, and then there is going to just find for 3.8 to the one that we have there. So inside this path for executable is my python.exec there under the command line. So if I just go back and search it again, and then let's see, Python 3.8. Okay, so if I just don't like it in that window, I could say type p.text and then do a find/i Python. I could do that also. On Unix, you could do a grep commands there. It will find it there, but then again, this is like my path command. So it is not just picking up exactly what I want to do. I could open like Atom if I just want to use p.text and just see a different contents of it than the notepad, because notepad was one line completely. So if you just feel like, no, actually, I'd rather open it in another editorial, it's your choice. You can make that one there. Let me just also open up a VirtualBox Linux so we could practice Linux as well. Actually, I don't need to do that one. I could just, sorry, I closed the wrong one. Hopefully I did not close it. Yeah, so I'm not gonna open up, yeah, I closed that one. I'm not gonna open up this one because this one is gonna take a little bit more resource. So I'm gonna open up session from my Linux Mint Bitwise. I'm gonna connect to that machine. This is if I want to run Linux Mint, another session, I'll show you how to do this one and how to build it. But right now I want to show you from Python command line those kind of concepts, so you understand how to manipulate it with Windows environment as well as a Linux environment or Mac environment. Linux and Mac is very much similar. The only difference is maybe 10% or 20% device drivers and certain commands are different, but VI and Python and other modules are going to work the same way. The command lines are System 5 Release 4 mostly, and then some of them they also support like System D with Linux, and Unix. Mac is based on BSD, Berkeley Software Distribution. So the concept of shell programming and shell scripting and Python scripting is matching mostly the same. except like if you load the OS module, the OS module might be showing you different commands depending on whether you're on Linux or Mac or Windows, whatever. You just have those choices to do it. So this one I'm going to connect to a Linux machine right here. The environment, you can set up one Windows machine to connect to multiple environment nowadays. It's so simple, so easy, especially with VirtualBox. So right here, I'm on a Unix machine. And if you look at it, the CAD EDC release OS-etc OS-release, it tells me it's a Linux and it is Linux Mint 19.3 version. So if I go here on Python, the 2.7.17 works. If I want to use Python 3, I type in Python 3 as the 3.69 is loaded. And then here, if I just say import sys like I was doing here, sys.path, notice that this path is different. This path is a user lib, not C:, or something, because this is Unix. And then if I just quit out of this and say path, notice that inside this command is not working like Windows. So I have to do echo uppercase $path. This will just show me the path. There's no path here with Python. But if I do which Python to show me where Python is, this is showing that a Python binary is on user bin directory. So the way the path works on Linux, it is going to look for user bin and the path, then it says, oh, I found out the binary that are Python. And then the way it looks for it, if I just say file user bin Python, this is just basically says it's symbolic link to 2.7. If I do with Python 3, it is that symbolic link to Python 3. And the way I know it, the user bin Python, it is symbolic link. This means symbolic link. It is Python 2.7. This L and the first letter here, that L is stand for a link, symbolic link. If it's a regular file, that would be a dash. If it's a directory, it would be a D. If it is a symbolic link, it would be L, and so on. If it's a block files, it would be a B. If it's a character file, it would be a C. The next three characters is for the read-write executable for the owner. The owner in this case is root. And then the next three characters, read-write execute for the group. And then the next three characters for other people's, other than root user and root group. And we will discuss some of those ones when it comes time to say how the permission works on Windows versus Unix. On Windows, if you look at this p.text, there's an attribute command, p.text, that would actually attrib command, which is a stand for attribute, and it says it's archive at p.text. If it's a hidden file, this would be a H. If it's a system file, it would show a S, and so on. And normally when you copy these files, the archive bit is shown blank after it copies it, so you can copy it, and then there's other command like xcopy and other days. Old days when we were just doing homework for the lab, since the lab would close at 9 p.m., a lot of the files that you're writing, you just have to copy them onto a floppy disk that was not fitting in one file. Then you just have to do the xcopy command, xcopy on Windows with star. First, you have to change the attribute of these files to make sure it is there. Then once you copy the entire files directories, then you do a xcopy with star, let's say, for example, everything into my A drive, for example, on the floppy disk. And then the next time you do it, you do /s and /m. /s for /s for subdirectories, and m is to set the attribute bit, so the next floppy disk will know that where to start off on the next one But those old days are gone, and now you have the luxury of using SSH, scopy, FTP, secure FTP, and rcopy. SSH and scopy is the command that you want to use basically, and they just allow you as many files as you want to do with -R for recursive copy. I'll show you some of those days someday, some of those commands. But we were talking about Python. So Python 2.7 is on this path. If I just do a user ben Python 3, also drops me to the same one. And then if I just type in Python 3, would also drop me the same one. So this is Linux. And then as I mentioned on your homework, if you do write up a script on Windows, for example, if you write here, if you write hello world, you just say vi hello word underscore wlutfi, for example, .py. I just name it like that. Then I say pound shebang. This one you could just say pound shebang and the user ben env Python. And then here I just say print the either double quote or single quote, whichever one you use, you have to be consistent with closing it. So now this is a simple Python script. And then now if I just show you this ls-l is like equivalent to the directory command with hello and .python. And then star is the wildcard, it's the same thing. So if I just say, show me this program, and then now you see this is showing as a dash, meaning it's a ordinary file. So if I do, instead of this ls, it says file, it shows that it's a text file. It's a text type of file because the content of it, I can look at the content of that file, hello world, and then it says that this is the content of it by concatenation command cat, or I could just type in more, it will just do the same thing and display it. If I want to list that file to say this is the file, this shows the owner, which is wlutfi. My ID, my user ID is wlutfi here. User ID, and then the group ID is also wlutfi. The group is this one. And this file, the group ID is wlutfi. So for this file, I have a lot of information that I can get. And then this one, it says the owner wlutfi has read, write, but no executable permission. The third one is the execution. If that one is not set, that this file cannot be executed. And then the next one is read, write, and dash. So this is the difference between an executable file, hello world, and you can see that it is, I'm running it like this. If I just say run it with hello word underscore wl.py, it says this one is permission denied because it's not executable. But if I just do this one with put a Python in front of it as a Python script, then run it, it execute it, even though the permissions is not there, because I have the first line here as user ben env Python. So the Python interpreter, which in this case is user ben env, it's going to run it and it's going to execute it. If I want to just not type in Python and it looks at this first code of the line here, I could just do change mode 755 and then hello star.py. Now I just change the permission of that file to show, and notice that Linux changed the color, say this is executable. Because this bit is now executable, I can just, the permission is changed to 755, read, write, execute for owner, read and execute for group, and read and execute for others. So anybody could just say hello underscore word underscore wl.py, it will just say hello world. They don't have to put .py. Similar to that one, if I do that one on Windows environment, here I could just write a notepad hello underscore w. Let's say I'm just going to say hello wl.py. And then I just here I put the first line, I say pound shebang, and then I say Python. Over there, I was putting user Benny and V Python, as you could see it, and then on the Linux, and then right here, let me show you the Linux. Right here, as you can see, I was putting this for Linux. Here I put pound Python for Windows. So then I say print hello world. And then if I just want to use double quote here and double quote here, that's also okay. As long as I am consistent with starting with double quote and closing it with double quote. So this one, now I save it, and then I name it, let's see what I wanna put it under lecture, for example, hello underscore word underscore wl.py. So I want to just save it exactly like the other one, and then I want to go here under, and because I started this hello world, I didn't save it here .py, so it's not here. So I have to go on my users Wahid, and then pasadena.edu, and then CIS star fall, and then go to lectures, and hello world wlutfi, and then you see that the date and timestamp of this one is today. So on Windows, if I want to look at the content of that file, I say type, it will show that one. If I want to run it, because Windows automatically associate the extension, I don't have to make it executable, automatically does that. I could also run it like this, Python. It runs at this. I could also go on Python, and then Python, and then say import hello. So for example, before I do import of it, if I do a dir of this, you can see that these are the objects that are available for me. Now I say import hello word underscore wl. Notice that I did not put the extension. Automatically it ran the code and it says hello world. Now if I do a dir, hello world is there as an object. So what is that one? If I just say dir of hello word underscore wl, it is just going to show that that is available for me, and these are the dunder method that I can apply to that object. For example, if there's any documentation for it, I could see it. If there's any built-in variables, what is the name of it, and all that things, I could get it. Like let's say I say print underscore underscore name underscore underscore, then it will just give me this. And then if I use it as a method, it does not say this is a string. So you have to do the object and then the name afterward. And then with that one, if you want to do with title, whether uppercase, and change it, and because it's a string, you could do manipulate it there. Let me see one other thing that I wanted. If I just say type hello underscore word underscore wl, you can see this is a module because I wrote that .py, automatically it shows a module. But if I say x is equal 5 and then I do a type of 5, this says it's integer. And then if I do change the x to 5.5, make it a floating point numbers, and then do a type, x is going to say it's a float. If I change the x to a string, say, and this is a simple test, and then I get the type of it, it says it's a string. So what I'm showing you here, as you change a variable to a different data type, Python does not care because Python is dynamic um, binding. It automatically binds to the data type it does. In other programming languages, as soon as you declare a variable, like if you say int x in C or C++ or Java, then automatically that's an integer data type. If you do a character C, then automatically that's a defined character. You cannot you cannot change it, but you can always cast it from one data type to another one on both programming languages, whether it's C or Python. Casting is when you are changing the data type from one data structure or one data type to another one. For example, let's say I create this X to be there as a string. I cannot change that one to the number because this is a simple test is not there. But if I say X is equal the string 5, then I want to say X, now print this one, the type of X is a string. If I want to change that one to cast it to integer, for example, X, and then that would just actually print the letter 5. And even though print of this is going to show an integer, and then if I do a type of it, type around it. So this is a concept of object-oriented method of Python that you can just use one method on top of another method or a method dot properties of it to get the information. And then on that concept of casting, so for example, X is equal 5, I just changed it to integer. Now I want to get the data type of it. It says integer. If I change that one to a float, from X, which is a string by default, by that definition earlier, it is just float now. And then if I just don't do any conversion and I just do this one, notice that it's going to be this because 5 is a string. So from one data type, you can convert to another data type, or you could just simply assign something like a different data type for it. Like this one is a Boolean type. If I type in X now, then he says it's a type of class Boolean. So you could constantly or dynamically update from one data type to do it to another data type. That's options there. Let's go back to this example. So we run this as a simple Python example, and then running interactively, running Python script from the command line. So from command line, if you're on Windows, you could run the Python script here. Let's say we have a script called type var and var1.py. So in this case, I'm importing math as m, import os, and then from random import random init, which is random integer, and then I'm doing some manipulation with power function, and then get the square root of the power functions on top of getting the power, then I get the square root of it. So 2 to the power of 4 is 16, and then a square root of that one returns 4. And then here a power of 2 to the power of 10 is 1024. And then print random int, it's just print random generated numbers. And then here we're running for I in range. This is the for statement. We haven't talked about for statement. We haven't talked about if statement, but I'll show you a lot of those ones as we go through chapters. Each chapters will be dedicated for a different statement and different looping condition, different examples I will give you. But as we are discussing, I'll go back and forth between these concepts and find out what we can learn as we go. So if I just want to run this Python program there, it will just do all those one. The first one was 1024, like I said, to the power of 10. And then the square root of 16 was returned to 4. And then the other numbers are generated based on these other examples here. So in order to do this one, let me just do dir var1 Python. I'm going to do open Adams. We open it. Let's just see what was under Adam on this. So like right here, you can see under Adams, you could do edit, find files. Let's see, edit. Select grammar, go to line number, and it doesn't have a find edit statement.
There's a find tab at.
I'm sorry, where is it?
There's a find tab at the top.
Find tab?
Yeah, next to selection.
Next
Not sure if it's gonna work. Yeah.
Yeah, thank you. Find text, so you could look for that one. You can tell that I don't use Atom. So find tab and then find text, and it should work with this. So this is something that I just don't like GUI stuff. Sometimes when they don't work, there's no option for you to just get it. But sometimes, I mean, if you have to use it, most likely there's an option like find and next and replace it. Like let's say find all, and why doesn't it see find?
Maybe if you try find and buffer or find and project.
Like, yeah, it looks like it is slow. Maybe, okay, find buffer. So I'm looking for Python. Let me show you how easy it is on this one on Notepad, or I mean not a Notepad, on Linux. So if I go on Linux here and then do search for something, if let's say the file is like this long listing, and then I could just send it to a file called file.txt. Now I just created the file.txt. I could say cut a file.txt, and then at this time I could just say grep -i. Let's say I'm looking for this word public. I could say public, because -i is a lowercase, it just does that. And if I just want to do only get this one, not the other ones, I say this is field 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9. So then I could just say print for awkward programming, print $9. And then on the PowerShell, you could do that same thing with the whereas command and other ones. So you do have it on the command line. You could just see I picked it up here. But if I just say, okay, now let's say file.txt, and then I just want to search for it, like we were doing in Adams, and this search on VI is the word I could search for public, and it's going to just jump into there. So if there's more, if I want to just replace that one to say $1, $, substitute public to let's say Wahid, I could just change that one globally, and now just change it to Wahid. If I just do whatever I want to do is within this editorial, it gives me more flexibility to do it. The issue with Notepad and Adams and other ones, sometimes it can give you certain limitation, but it's not extensive to do it. So for example, if I just want to delete, let's say I want to set a line number, set in you could see the line numbers there. if I want to say, go ahead, delete the line number with Wahid, which is 12, I could say 12D, sorry, 12D, and it will just automatically delete that line. And if I just want to delete from line 12 through 16, I could say 12, 16, delete. And if I just say 1, $, delete the entire file. If I just say undo, it will undo it. If I want to just say copy, let's say line 11, I do YY and then I paste it as many times, the same thing, I could do it. I could change something like within certain lines. So for example, this picture, I want to change it only on line 10. I could say substitute from 1, 10, look for the word pictures and change it to Wahid. And then that will only change, actually I had to do it from 1 to 11 because on 10 we don't have the line. 1, 10, 11. Let's say I want to do only these two lines. I could say 11, 12, substitute then pictures to Wahid. And then G for globally, it will just modify those ones. If I just say, oh, I made a mistake, I want to do another one, undo, and just you undo. And if I just want to write and quit, it's done. Now the file is modified with the name. I just want to delete it, rm file.txt, that file is gone. So, I mean, the manipulation of these files should not be too hard to just go like something and search for it and it never finds it. Like on Notepad, we had to struggle to look for a file. But sometimes if the file is in a nice format, these tools, it could give you find and replace easily and then just search for it and replace it. Like here, I could just search for Python and then it will find it. And then here, when we did the find, everything is in the buffer. Let's see, find, if you go find buffer, the contents of it is maybe, let's see, common. It does not highlight it or something to just say you're looking find and replace, let's say, find next, find previous. So replace all. Let's say if we just, yeah, that doesn't check it. I wouldn't. I mean, you could try to see if there's options for it to do it, but it is not an easy editorial to search, delete lines, and for finding it. Okay, so I'm going to close that one, but if you need to download it, it is adam.io. You go there and then download the Adam text editorial, and then once you download it, maybe I need to upgrade my version to work smooth the way it should, but maybe I don't. I'll just upgrade it anyway, because I might have the old version. So once it's downloaded, you just basically go to your show all, the download.exec, which is coming here for Adam setup. You run that one, and it will go for 64-bit OS on Windows. It will just do it. Okay, so still not readable for, okay, no. Come on, didn't mean to do that. I just want to run this one. this one is the one that I want to run. For some reason, even the command line of that one is running slow. So I could go here under users, Wahid, and downloads, and then look for a directory. Everything that I just, this /o means optional, D means descending. So it shows at the bottom and the last files that are downloaded. So this is the file that I want to run. I could run it from, since it is Adam setup dash x64, I could just, since it's a .exec file, it's executable file, I could just run it by that. And that's gonna just open up the Atom installation, which is right here. I'll upgrade mine and see if maybe the search and other things could work better. Normally, if they give you an option to search for something and you click on it and it doesn't work, maybe it is a little bit slow. You can see that some of the things that is happening will take a while. I wasn't patient enough to just wait for it, and I'm not going to wait for Atom installation anymore. I'll just let it run on the site while we're doing the rest of the lectures. So running Python interactively, we did that one. Running from command line, we covered that one. Okay, so we downloaded the modules, SES modules, and last week we downloaded OS modules. We will be doing a lot of modules at the later chapters. I'm going to show you the help, type, and dir commands next. Do you have any question for me before I cover those topics? Okay, I see 18 people are logged on. Before I jump into help, type, and dir, let me do a roll calls, and that way we make sure that I have an up-to-date attendance sheet so I can drop those ones that are not attending a class anymore after this session today. So actually 18 people, there were 17, so 17. 8, 10. Let me do a roll calls right after our break. When we do a break, I want to make sure that everybody attends after the break, so we don't have to do roll calls twice, and then we could do the lab activities after that. So I will not do the roll calls now, I'll just do the roll calls after the break. But for the Pythons, we will discuss help, type, and dir. Let's discuss those ones. So I could do that one in command line Windows. What is this? Atom install shield.exe, close it, and close it. So that's what happened with Atom somehow, maybe because this one was up and running. Actually, this is the only one. Close, and I'm going to make sure that there's nothing else is running, see if this one is going to fail or is going to work. Okay, so here I'm going to do clear screen and then run Python. As you know that whenever you're in Python environment, you don't have to worry about where you started on Windows. You can start from anywhere as long as it's in your path, then you could do it. So on this screen, I want to first clear my screen. In order to do that one, I could install, load OS module, import OS, and then say OS. If you do a dir command on OS, remember dir is going to show you a whole list of the methods and properties that are available for that modules. So in this case, when I get into Python, by default, These are the one. But if I just import OS and then do a dir on OS, I get these ones. So this syntax of import OS, if I do import OS as O, then now I have a dir of O and the same thing as dir of OS. So these are object, the same thing that are there. And then O dot system or os.system is the same thing. So I'm going to be short on it to say o.system, which means os.system, and then I'm going to do a clear screen command on Windows, and then that will just clear my screen there. And so the dir command by itself, if I just run it, it shows what modules have been loaded. By default, annotation built in docs with 3.5.8, it comes out with all these ones. Now, in addition to whatever other modules that you loaded, it just loads those ones, O and OS. And if I just want to do an ID of this O, you could see that is the same ID as OS. And so because they are the same modules that are pointing to the same things. So let me just do a del O, and then that deleted that module that I loaded as O. If I do this one, it's pointing to nothing. Now the dir of OS is still giving me the information. ID of OS is still gave me the value. And dir by itself is not going to show O anymore because I get rid of that object. Okay, so I could just import OS and then do the os.system and then run the command like in Windows. And if I want to get the detail of my system information, you could run the system info. So the dir is one command, and then once you have loaded, notice that inside the OS there's one module, dir of OS, there's one module called sys. So if I just say type os.sys and then .system, I'm sorry, and .system, then you can see this is a method, right? And then if I just want to do change that one to a help, it will just tell me if that one is a module that I can run Linux commands or Windows command in this case, system and then command. So one of the system command that I could say run was os.sys, and then instead of this, let's say if I just pass on the directory command, it will just do the directory command. Since it's all the py script, I could just, the list is really long, so I'm on the download directory. If I say path, it will just give me the path of my system. But then notice this path is the OS path, and then import sys, and sys.path is different than that path. This is the Python path that the Python executable does. So if you just run this command, or just let's say the tree command to get a listing of all the trees of the Windows, you could run these commands from the command line or from Python os.sys modules, because within the os.system you could run any operating system command here within this code. So if I just say echo this is a test, this is a test, and I put those one, it will work exactly like I was expecting it. If I just say give me the Python version, Python-v, it will just tell me that. And so any command that I know on Windows, it will just be executed here. If I just say give me the help command there, it will just give me the help command. If I just say give me help with type, for example, type display the content of a text file, it will just do that. If I want to say help with Xcopy, let's say it will just do that. The syntax of it is going to show. And if I just want to say, maybe run a PowerShell command, now it's going to drop me to a PowerShell command from Windows. And that's exactly the PowerShell things that is available. And then I have to exit out of the PowerShell when I'm done. And then I just, now look at this, my prompt changes to PS from the Python. Because of this os.system PowerShell, it dropped me to PowerShell. Inside here, I could type in a PowerShell command, like get-help is just Python, PowerShell command. If I say aliases, it will give me a list of all the aliases that are there. So a lot of the commands that I, get-alias, it will give me aliases, or some of the command like process, like I could type in PS as an alias and get the system processes, all the process IDs with whatever is running on my system, everything. So the powerful thing about Python, it does not restrict you to do anything with something that you have control over. Whether you're in one environment or another one. Now by typing exit, I'm back on Python. So I could just say, what is 2 plus 2? It is just gonna do that one plus 3. It doesn't matter how many other operators that I'm using, it will just do those calculations for me. As you can see that as you type in, and if I just divide it by 0, this is not allowed. It's going to just throw a floating point division by 0 error. So if I just say print, this is a test, you could do that one. Now if I put double quote here, it's going to say end of line while scanning a string. So it was looking for the closing of this string, and it found a double string. So on my statement, I could just change that one to a double quote and it will work. Or if I do this one single quote, it will still fail. Because it started with double quote, I did not do a double quote in there. So then that is not going to work. And the way you correct it, whatever you start with, you finish it with that. So in Python, sometimes you could also get help. If you type in help by itself with the method type help, it will drop you to a help prompt. And from here, you could get additional help, like you get information about modules, keywords, symbols, topics, and everything. So let's say I look for topics, all these list of topics, you could search for it to do it. And then some of them are data structure, like list or data dictionary or integer or float or string or tuples. But some of them are other types. For example, Boolean, for example, if you just are looking for true and false values, and you're looking at data type Boolean. I'll show you some of the examples when we get back out of the loop, out of the help section. So in this case, let's say I'm looking for keywords. Certain keywords like if statement, while statement, for statement, try statement, exception statement, all of those ones are part of the keywords, reserved words, they call it in a programming language. There are keywords that only Python have allocated as reserved words, and they have certain syntax. So if I look at the syntax of if statement, it will tell me if some assignment expression followed by a colon, then a suite of other commands, and there's else part, else part, else if part, and then else to end it. I'll show you all those examples later on today with if statement, for example. And then if you're looking for a for statement, it tells you the syntax there, and it gives you for x's in this a sub list. This is a list, and then manipulate it and remove each element until it becomes the list is empty. So sometimes you could get for the while statement similar. And then if you want to get the list of modules, all the modules that are in there in Python, you will get a list of them, and each modules, let's say you work with math module, you could get help from there. And the list is huge, so that's why it's taking a while to generate the list for you. And let me just, while this one is waiting, see how fast is it on Python 3 with Linux. So here, if I just say modules, it will just take a similar time, maybe faster. It was a little bit faster. You can see, actually, they did not generate this one because it needs some other modules to be installed. So let me get out of here, and I used Python 2.7. And actually it did eventually show, but whether it is going to return the same error, we will find out from Python 2.7. Modules, okay, modules. And yeah, so Python 2.7, it was faster because all the modules are already found because of the version, and that is configured on the environment variable. So if I just exit out of this and say which Python, you can see the user bin Python 2.7 is going to be loaded right away. So here you get the modules. Let's say if you say a math module, you could get the help on it like this too, and then see what functions are available for it. So within the help, you could get a lot of information from here, or you could just say by pressing enter and not typing anything, it drop you back to interpreter. So you could also get here help by saying import math module and then say help math. This way you could get the help also, the same help, but now I passed on. If I just say import math as M, then I have to do help M. So whatever module you could did that one, that would work, it's fine. And then I was showing you about Boolean data types. So let me clear my screen. This time I'm not going to clear my screen with the OS modules. I'm going to write my own function to do it. I could write a function, or I could do a simple print statement with a new line character. Okay, new line character, and then a comma, and then 50 times 50. This is as simple as it can get with print statement, and then get out of this comma. That's what was the problem. So if I just say 5, okay, sorry, one more thing I'm going to show you on the help with the operators, because you need to know this information. So if I just look at the operator like a plus symbol, right? There's a lot of operators that are there, lambda functions, if statement, or statement, and not. And there's also these other Boolean operators that are called sometimes assignment statements and Boolean comparisons, like less than sign, less or equal sign, greater sign, or greater or equal sign, a not equal sign, the or statement, the bitwise XOR, and the bitwise and the statement. All of this, you could get these information from the help by typing one of the character. Like for example, if I do the minus, it will give you the same thing. If I do a plus, it will give you the same thing. If I just do a multiplication, any of these operators that you see on the list, like for example, less than sign, it will just bring out the same information repeatedly, because like for example, let's say or, for bitwise Boolean operator, not bitwise Boolean operator, it will just say when you're doing comparison A or B or X or Z. And this one, if I use the AND comparison, and these are operators that you're called Boolean operators, that based on the result of the values, some instruction will be executed. For example, if I say 5 equal 5, that is true, right? So I have to exit out of this and now say 5 equal 5. Is that true? Yes. 5 equal 1? No. False. And 5, anything that you do, like 5 less than 4, that's false, right? So it will have to return this. But less than 14, yes, it's true. But now if I just say 5 is less than 5, it says false. But if I say less or equal, this will be true. It is not less, but it is equal to 5. So if I just say 5 is greater than 5, that is false. But 5 is greater or equal, then it's true. Notice that the symbol that greater or less is put before the equal sign, not after. That's important. When you do this, you don't write it less or greater. This, it doesn't work. That's not the syntax. So when you were on help, if you look at the greater or equal sign, that will show up as greater or equal sign, or less or equal sign, but not the other way around, equal in front of them, or in front of them would not work. So now you know those conditions. So inside here, if I say 5 is equal 5, that is true, then I could say in a if statement, if I say if 5 is equal 5, then do something. Then here I'm on the next prompt of the if statement, because I put this colon. This colon says that this statement is going to be executed, followed by another statement. So the next statement, if I just say print here, watch, if I do print here, it's going to just give me a syntax error. It's going to just go with an error because it says expected an indentation, which means after this if statement, the way I did it here, if I just move this one 4 spaces here, it will work. So now it says print error. Obviously, this does not make sense. If 5 is equal 5, print error. That is semantically does not make sense. So logically, the 5 is equal 5, and then your statement when you're doing it, if you say if 5 is equal 5, let's say here I do if 5 is equal 5, then instead of say print error, let's say the number 5 is equal to 5. So that would make sense to say that, yeah, they're there. You could just say if 5 is equal 5, and then say this, and then right here you could put else, say print, again indentation, print the number 5 is not equal to 5, right? So this one is going to just print the number 5 is equal 5. It will just finish. It will not go to the else part. But notice if I just change this one to 4, okay, and then say the same print statement, same else part, and same the number 5 is I have to say the number 5 is not equal to 4. And then the other command right here, the number 5 not equal, I had to change it to 4. I missed that one. So you have to do that one there. And then now it's going to come to the else part and says the number is not equal to 4. So the comparison is important. Like here, I put if statement, and then I say if the number 5 is not equal to 4, and then say print the two numbers are different. If the two numbers are different, and then right there, it will just do that one. Now let's assign x is equal 5 and y is equal 4. And then instead of using this kind of values, we use variables. So on assignment statements, a variable is basically a placeholder. You assign the value of 5 to be onto the memory variable called x to hold that one. X is like a box that inside of it, when you look for it, it holds that value of 5. And the storage and computer, normally there's a data type for it. So x dot underscore underscore size of, it is going to show you what is the size of that and bytes, the number of bytes that it takes to hold the x. And the same thing for y is 14 bytes long. So if I just say name is equal the variable in Wahid, this one by itself, one character and as a string, name dot underscore size of is a 26 character. So if I change name to Wahid, 26 plus 8, 1 is 27, 28, 29, 30. So now if I just do this one and then print that one, it's going to show 30. So if I just change this one to a space Lutfi, that's 31, and then 5 other one, 36. So now the name.size of is 36 bytes long. Same thing with a floating point number. So if I declare a variable called f, and I put 5.9, now I could just get f.size of, then it's different data types, so it's 16 bytes. A float is larger in memory and then a string, then an integer, which is x in that case. And then a string is larger than a float. And the way the data is stored on memory, it takes a certain amount of bytes of characters in order to manipulate that or save that record into memory. So what we were talking about here is the comparison. So if I just say x is equal 5, y is equal that, then I could say f x is equal y, then let's say print, let's say print x, if it is there, okay? I could just say the value of the values of x and y are the same. As simple as that. You could do that. Else, you could say print x comma y. If you just they're not the same, then print the value for it to say what they are. And then since they're 5 and 4, you could do that one. Or you could just make it like this: if x is equal y, print they're the same, and then else, and then you could just say, instead of this, you could say x is equal comma x, and y is equal comma y. Like that, you could also get it there. I just missed the x here, so and the equal sign here, so you could do something like this to make sure that your statement is accurate. Right here, put the equal sign and then get that one there, x is equal 5, y is equal 4. And then notice that I did not put this. You could also do something like this, okay? So you could say if x is equal y, and then print it, they're the same, and then else do this print statement. You could just say print, and instead of doing this way, you could just say x is equal plus x, and then comma y is equal plus y. So now the problem is that because I'm doing this one as a string and this one as integer, it will fail. So that means I have to change this one to a string to print it out. I have to cast that one to a string because you can only print out two strings in that sense. So that this way is there. So notice if I just do print this word x by itself is equal, this is a string, then I say plus x, is not going to work because one is a string, the other one is an integer. So I have to cast it. You see that? It says cannot only concatenate a string with integer. So in this other statement, it worked. So in order to do that one, either I have to do something like x comma, like this to print it, or just if I want to put the string x is equal that, then I have to say plus concatenation and convert this one to a string data type. Then that would work. So there's options for you for Python for a number of things that you can do with printing statements and manipulating the data with comparison of certain things. So if I just say true is equal true, this is going to return true. If I say true and is equal false, that's not going to be true. And then if I just say true is greater or equal to false, then it's going to say true because T is greater than F, the letter in ascending order. So if I just say is less than or equal, it's going to show false because it is not equal and it is not there. And so, but if I change this one to true, it's going to be true because it is not less, but it is equal. So there's comparison assignment statement, and then there's not equal sign, and that if you could just say, we already did that one. You can also check a string. So for example, in a string, I use name. I could say named, and then if I want to look at the property of each of these one with the dir, I could say these are the commands that are available for me to get it. Type of name will just say that this is a string class. So since it's a string, with a string I can do certain things. Like for example, if I want to change it everything to upper method, and then I could just say change it to upper. If I want to change it to lower method, to lowercase characters, or if I want to just capitalize something, capitalize and then the first letter is capitalized there. So there's certain things you can do. You could split it, for example. So Wahid is there, and if you just, I'm sorry, name is Wahid Lutfi. If I say dot split, by default it's gonna split it by the space. You can see it puts it into a list. So I could say I want to print this name, each one of them. Now it's a list. So a name sub dot sub 0 is going to give me Wahid. Sorry, name dot split. Okay, so we split it. Let me split it first. it prints it that one. So the way you do this one, you could just assign it to n, for example. Now n has the list, n sub 0 would give you Wahid, and n sub 1 will give you Lutfi. Or you could do something like for I and n, and then say for spaces, print I would just do the same thing, that print each one of the items in the list. So sometimes you can create a list, for example, the data type called, let's say my list. If I have a variable called my list, and then I just create an empty list. This is type of my list now has a list that is pointing to no elements. Okay, so if I could want to do what I could do with my list, I say dir, and then these are the command that I can add to it and append to it and so on. There's these dunder method I could do, or I could use the methods like let's say for extend to extend the list, or append. Is there append there? Most likely there's a append method there. So if I just say my list dot append, add to the end of it and say number 1, for example, and then now I just get to print my list. It just has the 1 element, and now I say append 2, it has 2 elements, and then I just add let's say Wahid there. So the list actually grows, but it is not the same data type. Notice it is consists of a string 1, 2, and then a string Wahid. So if I want to just add a string, an integer, then now it has an integer as well. So if I just say for my list, for item in my list, just to traverse throughout the list, I could say print item, and then it will just print those ones. And then my item, my list sub 0 will be printing the number, the string 1. And then let's say if I want to do Wahid, that is 0, 1, 2, and number 2 would print Wahid. Number 3 would be printing the number 1. And then minus 1 also printing the 1 because it's end of it. And then length of my list, length of my list also I'm gonna be the same, but I have to subtract 1 out of it. Otherwise it says list index out of range. So subtract 1 out of it, it will just print you the number. Subtract 2 out of it, it will print Wahid. And subtract 3 out of it will print the string number 2, and so on. So, and then subtract 4, it will print the string 1, but then 5 will get out of range. Actually, with the numbers, doesn't matter in this case, yeah. So it goes back in the descending order there. So my list, this is not going to give you anything, but my list range this will give you from first element to the last element. And if I just want to say the first element to the last element, I could do that one, or -1, I could do that one, or could say start from element Wahid to the last element, only print Wahid, because -1 meaning that don't include the other ones. So if I just say include Wahid in 1, I could do this way. And that is the range, or on the order that you want to manipulate the indices of those elements. So if I just say my list, and then I want to just my list dot pop, if I want to just pop the last element, it gets it from that one. So now if I print my list, it's just having those three elements. My list.pop will pick up Wahid from the last one. And then you can also pop from the first order by giving an indice of 0. But in this case, it's almost like a stack, last in, first out. So whatever is on the list last, it will be picked up from this. So now if I do a pop, the 2 was last inserted, like almost a stack, like at, in a restaurant when you go there, the trays are on top of each other. The last one that was inserted is the first one to be popped out. It's not like a queue that is first in, first out. So and now I can just get the list. It's one element. If I want to pull one more, it is empty. Now if I just pop up more, it says out of range because the list is empty. You cannot pop up from an empty list. So with the strings, you could say name is there. You could do a lot of things with a string also. We will cover a lot of that one when we come to comparison statement like equality, change the font, change the, things that we have to do with it, splitting it and check if a string contains certain things. So like this string contains, you can see like in this case sensitive. So name contains Wahid Lutfi. And then if I just say name dot underscore underscore contains underscore underscore, if I look for Wahid, it's not going to return false because I put W in lowercase versus W in uppercase. And then if I just change that one to uppercase, yes, that string is there, it's going to say true. Then your if statement, you say if name dot underscore underscore contains underscore underscore, let's say Lutfi, and then say something. And then that something could say print you must be Lutfi, whatever that's you want to say that it just found it and it's there. And if you just say if this name is there, then you say yeah, I found you, Mr. That person name. So a lot of these options are there with Python. It's almost 8:50. Let me give you guys a break, about 10 minutes, and then we will continue on with the rest of the modules. And before we go to a break, does anybody have any question? Okay, if no question, please take a break. I'm gonna look at the chats. If anybody had any specific question, I'll stop sharing and I'll stop recording for now. And then when we resume, we may record again, going the rest of it, and then cover as much as possible. We already covered the variable condition statements and if statements. So we're ready for maybe in the lab session afterward. When we come in, we will do it together, or you do it and ask me for help whenever you need to. So let's just go back to break, and I'm going to stop recording now and stop recording.